So we're here today to talk about the Philips VeriSight Pro 3D ICE catheter. It's a catheter that we use in many structural heart procedures, specifically in tricuspid grasping procedures. It's really helpful to get excellent image quality. The setup that we have today, you can see we have a biosimulator beating heart. We have a Abbott TriClip G5, and we have the VeriSight Pro 3D ICE catheter. If you look up here, we have already set up and we have placed the TriClip over the tricuspid valve in this porcine heart, and we're ready to image. Let's assume that we've used TEE to already set up the scenario. The clip has been placed in the proper position. It's over the leaflets that we care about. We turn on our TEE probe to start to do our grasping step, and all of a sudden realize our image quality is not adequate and we can't see our leaflets. It's an excellent time to pull out your ICE catheter. So we've pulled out our ICE catheter and now we're imaging the clip. Let's get ready to grasp. The first thing that we'll do is choose our X plane. As you can see here, I have my green plane here, my lateral plane, and then this is my elevation plane over here at 0 and 90 degrees. Let's figure out what our grasping view is. So when I put my M line over the device, I'll just turn my seek angle until I see the widest arms of the device. What I see here is that our grasping view falls at 90 degrees. This is not an ideal image sometimes because image quality might be lower. What we want to do now is do our 3D navigation technique to try to improve image quality for this specific grasp. The first thing I'll do is choose two high resolution planes. Because we're centralized with this clip, I'm going to choose -45 and +45. Now you can see I have two very high resolution planes, but what I don't have is my grasping view. We've already decided it lives at 90 degrees. There's nothing I can do about that. I'm going to have to move this ICE catheter to get these high resolution planes over my grasping view. So that's where 3D navigation comes in. Let's go ahead and turn on 3D zoom. We'll align our boxes so that we have the entire annulus in place. You don't really have to put a lot of effort into this because we're using this for navigation. When I have my 3D volume, I'll simply pull that down. I want to make sure that both my lines are as straight as possible. That means that I'm really sitting on top of this valve. So the green line here, I'll turn the gain down. This green line here is our -45, and the red line is +45. My goal is to get this red line on that device, and that will give us excellent grasping. There are different maneuvers that I can do with the ICE catheter, so let's review those. If I advance the ICE catheter, we're going to watch these crosshairs here. So as we advance, you can see that the crosshairs are moving more towards our aorta. If I retract, you can see that the crosshairs are moving more towards the IVC or the posterior leaflet. We'll go back central. If I clock the handle, we look septally. If I counterclock the handle, we look more laterally. By the way, these are the exact same movements that they use for the TriClip device when they want to make adjustments to it. If you want to look more septally, you do clocking. If you want to look more laterally, you counterclock. So as you can see, I'm aligned on the device, but I'm not aligned with the device. So I want that red line on that device. So I have two more movements here that I can use. We have our right and left flex, and it's really, really helpful to use these in this scenario. So if you look at our image here, you can see the device is here. I would like that device to move to the red line. And you can see when I do that with my hands, that's a leftward move. So I'm going to use left flex on the catheter. So let's watch what happens when I add left flex. There we go. You can see that the device looks like it's rotating. It's not actually moving, I'm just moving the ICE catheter. And you can see with that left flex, I'm getting more aligned with the device. We're gonna flex a little more, and I'm going to advance. I wanna kind of be in front of it. If we image through the device, then we get shadowing. So my red line is now aligned perfectly with the device. I'll clock a little bit to get the green line up there as well. There we go. Now when I go to X-plane, and I move my M line over, you can see that we have dramatically improved the image quality for our grasping view. So that's what 3D navigation is for. It's a technique. It's not a step in the procedure. It's just a way to improve your image quality when needed. Now that was a lot of words. It takes a long time to explain that, but I'd like to demonstrate for you what it's really like in a case once you understand the concepts and you can apply them quickly. Step 1, find grasping view. Turn on my X-plane. I would turn seek angle until I get the widest clip arms over here in the elevation plane. I notice that the clip arms are wide, but my image quality is low. So let's move to the next step. Let's choose 2 really good planes. We'll go right into 3D zoom. We'll pull down our volume until our lines are straight. I'm going to turn down my 2D gain to see the device better. I'm going to make some movements. I can tell right now I'm going to need left flex. So I'm adding some left flex, and I'm pushing in front because we want to flex in front of the device. If we don't, we might run into the device. So there I am aligned. Back to X-plane. And now look at the image quality of that grasp. So it's really that fast. Once you learn the steps on the machine, the steps on the catheter, you can very easily improve your image quality.
Philips.